So we will be teaching you how to prove and verify trigonometric identities. But first, I will introduce to you the different types of identities that you can use in proving. The first identity that I will be teaching to you is the reciprocal identities. The reciprocal identity of sine is equal to 1 over cosecant, and for cosine is equal to 1 over secant, and for tangent is equal to 1 over cotangent.
Next up are the ratio identities. The ratio identity for tangent is sine over cosine, while for cotangent it is cosine over sine.
For the last identity, we have the Pythagorean identities. For the first Pythagorean identity is sine squared theta plus cos squared theta is equal to 1. Or it could also be 1 minus sine squared theta is equal to cos squared theta, or 1 minus cos squared theta is equal to sine squared theta. In order for us to get the other identities, transpose either sine squared theta or cos squared theta. The next Pythagorean identity is tan squared theta plus 1 is equal to sec squared theta, or it could also be 1 minus sec squared theta is equal to tan squared theta, or sec squared theta minus tan squared theta is equal to 1. The last Pythagorean identity is 1 plus cot squared theta is equal to cosecant squared theta, or it could also be cosecant squared theta minus 1 is equal to cot squared theta, or cot squared theta minus cosecant squared theta is equal to 1. For our first problem, we have a given of sec to the fourth theta minus tan to the fourth theta over secant squared theta minus tan squared theta is equal to 1. And now for the solution of our problem number 1. First, we need to factor the numerator. And then cancel the similar terms with the denominator. And convert secant squared theta minus tan squared theta into 1. For our problem number 2, we have a given of cos x over 1 minus sin x is equal to 1 plus sin x over cos x. And now for the solution of our second problem. First is to multiply cos x over 1 minus sin x to the denominator's conjugate 1 plus sin x over 1 plus sin x. And since there are similar terms, you can cancel them. And now we can say that cos x over 1 minus sin x is equal to 1 plus sin x over cos x. For our third problem, we have a given of cos x times cosecant x plus tan x is equal to cot x plus sin x. And now for the solution of our problem number 3. First is to distribute cos x to cosecant x and tan x. We also need to convert cosecant x to its reciprocal identity and tan x to its ratio identity. Since there are similar terms, you can now cancel them. And the remaining terms will be cos x times 1 over sin x plus sin x. And then solve and convert, and that will be cot x plus sin x. And for the given of our problem number 4, we have 1 plus cos theta over 1 minus cos theta minus 1 minus cos theta over 1 plus cos theta is equal to 4 cot theta cosecant theta.
And now for the solution of our fourth problem. First, we need to subtract 1 plus cosine theta over 1 minus cosine theta to 1 minus cosine theta over 1 plus cosine theta by using the butterfly method. Since there are similar terms, cancel them, then convert 1 minus cosine squared theta to sine squared theta. Since in Pythagorean identity, 1 minus cosine squared theta is equal to sine squared theta. After that, you will add 2 cosine theta to 2 cosine theta, which is equal to 4 cosine theta over sine squared theta. Sine squared theta can be divided into 2. Form now 4 cosine theta over sine theta multiplied by 1 over sine theta is equal to 4 cotangent theta cosecant theta.
And for our last problem, we have a given of sin x plus 1 over cos x plus cot x is equal to tan x. And now for the solution of our last problem. First, convert cot x to its ratio identity. And to add cos x over sin x to cos theta over sin theta, we will use the butterfly method. In order for us to complete the equation, you need to remove the denominator sin x so the equation will be sin x plus 1 times sin x over cos times sin x plus 1. You can now cancel the similar terms and convert sin x over cos x to tan x.
Cause I be the baddest.